Hi everybody, and welcome to the final video on tables. In this video I want to conclude the material on two-dimensional vectors by giving you a couple of examples. These examples are meant to get you more comfortable with tables, get you more comfortable with the notation, and they are meant to help you think about the table itself as a vector of vectors. So that's what a two-dimensional vector is. It's a list of lists. So one of these examples will help you to conceptualize the table that way. Okay, so I'm going to show you three examples. The first, I'm going to print the diagonal of a table to the screen. So just grabbing the main diagonal of a table and printing it. In the second example, I will reverse all of the entries of all of the rows, so write them backwards. And then I'll talk through how to swap two rows of a table. So we'll let the user tell us which rows they want to switch, and then we will switch them for the user. First, to do the diagonal example, we need a definition of diagonal. So the diagonal of a two-dimensional vector is the set of entries whose coordinate locations are the same. So the first entry of the diagonal is at position 0, 0, the upper left corner, and then position 1, 1, position 2, 2, etc. So if this is the table you are interested in, the diagonal is 1, 4, 3, because 1 is at position 0, 0, 4 is at position 1, 1, and 3 is at position 2, 2. So let's write a program that lets the user give us a table, and then what we do is we print the diagonal for them. So what would that look like? Let me go to the compiler. I've already preloaded some code in here just for the sake of time, so let me just show you what I've done. I'm going to let the user specify the size of the table, so the rows and columns. I then create a vector with those specifications in there. Then this nested for loop structure grabs the entries from the user one at a time, and then this nested for loop structure here just prints the table back. So the user enters the table, we then print the table back to them to show them what they did. Now after that, what I want to do is print the diagonal, and I want it to print like this over here. So in descending order, the way it looks inside the table. So what I can do is I can just, let me just copy and paste this. I can just go through the table entry by entry, just like this nested for loop structure does if I want to. But I don't want to print everything. You know, this nested for loop structure here prints everything. I only want to print the diagonal. So I only want to print if I and j here are the same thing. So let me just put that here. So I'm only going to print what's at the table if I and j are the same. That means I'm on the diagonal, so I should print. Otherwise, what should I do? Well, I shouldn't print anything, so I'll just print a space there. So it's the same printing for loop structure as before, it's just I'm not going to print everything. I only print if I and j are the same, if row and column number are the same. Otherwise, I'm just going to print a space, just to fill in the space around this diagonal. So let me just run this and see if it works. So first, I have to enter the number of rows and columns. So I'm going to do that first. So 3 rows, 4 columns. Then I'm going to enter this table from the slide over there. 5, 4, 3, 2. Okay, so once I hit enter, it should print the table back to me, which it does. Then it should print the diagonal to me, which it does. So notice this is the table I gave it. It just plucked out the 1, 4, and 3 and listed them in a descending line, just like they are in the table. Okay, so all of that to say that if you want to print just a part of a table, you can do that with some sort of structure like this. You just need a condition on what part of the table you want. If you want the diagonal, then the condition you need is row number equals column number. But maybe you want some other condition, you know. There's all sorts of little subtables you could print if you want to. For the next example, let's reverse all of the rows of a table. So we'll let the user enter a table, and then what we will do is we will write each row backwards and then print the result to the screen. So if the user enters this table, what we should do is create this table and print it. So 1643 becomes 3461. Okay. So how do you do something like that? Well, let me first just remind you that we know how to reverse the entries of a one-dimensional vector. We know how to reverse a single list because I gave you that command. It's literally the reverse command. Okay, we did it a week or two ago. So you can reverse a single vector, a single list, if you want to. Now in this case, you're not just reversing a single list. In this case, you are reversing 3 lists. So remember, a table is just a list of lists. So there's list 0, this is list 1, this is list 2. There are 3 lists here, and each list has 4 entries. That's how the computer is conceptualizing this table. So let me just go back here and get rid of the diagonal stuff. So how would you reverse a single row? So first of all, what I'm going to do is I'm going to set up a for loop structure that just lets me go row by row and reverse. So I'm going to start with row 0 and end with the last row. And then what should I do? I should reverse, and then what vector do I want to reverse? I want to reverse the vector that's at row I. So I want to reverse list I. And then the syntax is like this. I do dot begin dot end. Oops, end. Okay, so what's happening here? What is, like for example, my table bracket 0? What is that? Well, if I put like this, right? My table bracket 0 bracket 1, I'm saying the entry in row 0, column 1. That's a single entry inside of the table. If I leave off that second coordinate, this is just saying give me the list at position 0. So it's saying give me list 0, which is row 0. Because again, the table itself, the two-dimensional vector, is a list of lists. So this is the first list. It's the list at position 0. So in this case, it's 1643. This guy here, my table 1, that just means list 1. And since we start counting at 0, it's the second list. So that's 2448. And then my table 2, that's 5432. My table 3 does not exist because there is no fourth list at row 3, right? There's just rows 0 through 2. So what am I saying with this for loop structure here? I'm saying, hey, for 0 up to 1, up to 2, and then I stop at 2, right? What do I want you to do? I want you to reverse the list that's at that position, at row 0, at row 1, at row 2. And then when we're done, we'll just print the result to see what we did. Let me just throw in a few new lines. Okay, so the point of this example is that you can do things like this. This reverse command, that only works on one-dimensional vectors. It just reverses a single list. That reverse command does not work on two-dimensional vectors or higher. But a two-dimensional vector consists of one-dimensional vectors that have been stacked on top of each other. So you can just go through and use this reverse command one list at a time. If you have a table with just a single coordinate here, you're accessing the list at that row number. Okay, so let me just print this and see if it works. So I'm going to do a 3 by 4 table, and the entries are still as on the left there. So after I hit enter now, it should print the original table to the screen because that for loop structure is still there. And then it should reverse everything. Let's see if it does. 1643, right, becomes 3461. 2448 becomes 8442. 5432 becomes 2345. Okay? So it worked. So all of that to say that if you want to treat each row separately, you can. You access each row with a command like this. Okay, so to finish off this video, let me show you one more example. Let's think about swapping rows of a table. So what would that look like? The user could enter the table and then choose two numbers I and j. And the idea is that I and j are row numbers. And then we should swap those rows. So if they enter the numbers 1 and 2, we should swap the first and second rows. So if the user enters this table, the same one from before, if they enter the numbers 1 and 2, we should swap rows 1 and 2. So recall, this is row 0, right? So what I'm saying is let's swap row 2 with row 3, I guess. Rows 1 and row 2. Okay, so what would that look like? Let me come back over here and get rid of all of this. Okay, so far, this is again what I started with. This is just, we grab the table from the user and then we print the result to the screen. So now we need to get from the user a row number and a column number that they want us to swap. So let me now actually just print that to the screen. So which, sorry, not a row and a column number, just 2 rows, right? So which 2 rows would you like to swap? And then we'll get those 2 rows from them. Okay, and then what should we do? How could we, let me go back to this slide. From this table here, and now that the user has given us a 1 and a 2, how could we create this new table down here? Well, there are lots of ways to do it, but the way I'm going to do it is the following. I'm going to make a copy of this row and a copy of that row. So I'm going to copy both rows. Then once I have those copies in hand, I'm just going to take the copy of this row right here and just overlay it on top of this one, and vice versa. I'm going to take the copy of this row right here I have, and I'm going to overlay it on top of that one. There are other methods you could use, but that's what I'm going to do. So I just copy both rows and then paste them where I want to paste them. Okay, so now let me just create a couple of vectors. So vector int. This will be row I, the row corresponding to the first row they specified. And how big is that? It's columns big. Okay, so why columns right here? Well, notice this table here, right here, this is 3 by 4. There are 3 rows, 4 columns. So since there are 4 columns, each row has 4 entries. So each list has size 4. So that's why when I declare a couple of vectors right here, I'm going to give them size columns. So row I, row J. Okay. Now I want to make a copy of row I from the original table. So how can I do that? Well, if you keep in mind the notation I just showed you, it's actually pretty straightforward. You can just say this, row I. What do I want that to be? I want that to be row I from the table. And there you go. You've now copied the ith row from the table into this vector right here. And same thing for J. What should row J be? Well, it should just be the jth row of the original table. Okay, well, once I have those copies in hand, now what do I want to do? I want to swap these things. So now I'm just going to say my table at position I, that should be row J. And my table at position J, that should be row I. Okay, so done. You just made your 2 copies, and then you pasted them where you wanted to. So let me see if that worked. So once I've done all this copying and pasting, I'll just reprint the same table. I've overwritten it. Okay, so it's a 3 by 4 table, 1, 6, 4, 3, 2, 4, 4, 8, 5, 4, 3, 2. Okay, so which rows do I want to swap? I want to swap row 1 and row 2. And notice it did it, This row 2 has become row 1. This row 1 has become row 2. Okay, so anyway, if you're comfortable of thinking of tables as just a list of lists, then this kind of thing becomes pretty quick to do. Now in class, I'm going to have you guys swap 2 columns of a table. That's harder, because when the code thinks of a table as a list of lists, it's thinking of it as a bunch of columns stacked on top of each other. It is not thinking of the table as a bunch of rows stacked side by side. Okay, so let me say that again. The computer is thinking of a table as a bunch of rows on top of each other. It's not thinking of things as columns side by side. So if you wanted to swap two columns, you need to do something besides this. This won't work. So let me show you a different way to do this copying and pasting that can help in class. Okay, so instead of, let me just keep this first, but let me get rid of this. So I've made a copy of row I, right? It was table I, row J was table J, right? Suppose that you couldn't just write these little commands that I erased. Suppose you couldn't just do this, but you still want to replace the ith row with the jth row, as we've done here, right? And the jth row with the ith row. How would you do that? Well, if all else fails, you can always go entry by entry. So I'm going to go I equals 0, I up to the number of columns, because that's how many entries there are in a given row, I plus plus. And then what do I want to have happen? I want row I at a given position. I want, sorry, I've already done that. I want my table at row, where do I want it? What did I call it? Yeah, at I. Okay, so it's going to yell at me for using the same letter twice. Let me change this. So you can't use the same letter for multiple things or the computer gets confused. Okay. So I'm in row I, and then I want to just go entry by entry. So this K is going to range, right? And what do I want that to be? I want that to be row I at position K. So in other words, instead of just literally doing the copying and pasting with a single equation command, I just go entry by entry through this row and replace things. So my table in row I and then column K, where K is changing, that's just supposed to now be this copy I've made. Although this isn't doing anything, right? I want to actually copy and paste the other row. Sorry. Yeah, so I want row I to get put on top of row J. So I need that to be a J right there. And then you can do the same thing with the other row. So I want now the ith row inside of my table to be this copy of the jth row. So all of that to say, this is now more complicated than what I had before because it's just going entry by entry using a for loop. But this is the kind of thing you would have to do if you were doing some other kind of swapping, like swapping columns. So let me now just see if this works. Okay, so it's a 3 by 4 table. 1, 6, 4, 3, 2, 4, 4, 8. Okay, which two rows? I still want to swap row 1 with row 2, and it did it. Okay, just like it did before. Okay, so again, let me just explain what these for loops are doing. This for loop here, it's just marching through the jth row one entry at a time. So the second coordinate is changing as you march through the row. And what are you doing? You're just taking the kth entry of the I row and putting it there. So you are literally taking this copy of row I and laying it down on top of row J, and you're doing it one entry at a time using this for loop. And then the same thing for row I. You're just going through row I entry by entry. So the K coordinate is changing. So you'll start at I0, then go to I1, I2, I3, etc. And every time you do, just take this copy of row J you have and take the entry and overlay it on top. Okay, so this is the kind of thing you would do to swap columns. Again, you can't just do this kind of thing with columns because the computer is not thinking of the table as a bunch of columns. It's thinking of the table as a bunch of rows. Okay, so hopefully these three examples combined are sort of what's needed to finish off this material. So these last two, right, we exploited a couple of times that a table really is a vector of vectors, but all three of the examples require the use of the table notation, and that's what's generally hardest to do. Okay, so I'll see you in class.